scroll down.
Okay, minus by minus by omega naught L over 2, right? This is our equivalent load magnitude multiplied by the distance 2L over 3. Okay, so we know that the distance 2L over 3. Then By is going anti-clockwise plus by By multiplied by L. The whole thing will be equal to 0. Okay. Then from here, we know that moment at point A is equal to omega naught L squared over 3. Right, omega naught L squared over 3 minus by By L. Okay. So this is our equation number 2. Okay, for a moment. So now we use our positive shear and positive bending moment. Okay, so we are going to find from point A to point B. Okay, 0 x to L. So over here, what we are trying to achieve is we are trying to find the moment equation. And relate to elastic curve. Okay, so what I'm trying to tell you is this: we don't need to find the shear force. I repeat again, we don't need to find the shear force. We immediately can deal with the what? Bending moment. Okay, and why we cannot deal, we don't need to find the shear force is if you look back into this equation or into this boundary condition, we don't know any condition for our shear force, right? We don't know when x equals 0, what is our shear force. When x equal to L, what is our shear force? We don't know because the structure is what? Statically indeterminate. So immediately you can form your equation in moment, and then your moment equation will have the function of ay. Okay, you don't have by anymore. Okay, so coming back to here, I'll show you what I mean. Once I start writing up, it will be very much clearer for you guys. Okay, so now we are going to analyze the structure from left to right as before. Right, so we know that over here we have a moment, right? And then over here we have our ay, by, ay, okay, is equal to omega naught L over 2 minus by by, right? Because we want to find what is by, yes or no? Then omega as a function of a, or omega at a is omega naught L squared over 3 minus by by L. Then we know our equivalent load is equal to omega naught x squared over by 2L. We know the distance from here to here is x over 3. We know that the distance from here to here is x. And then positive shear, positive bending moment, this is m as a function of x. As I said, we only need to be bothered about m as a function of x. Okay, so we're going to take the moment at the dot over there. Okay, so we are going to write up positive summation about moment z at the variable anywhere at point x. So this will be equal to, so we have to consider the omega naught L squared over 3 minus by by L. Then the ay will induce a clockwise rotation. So minus, right, minus ay or omega naught L over 2 minus by by. This will be multiplied by x. Okay, and then we will have a plus omega naught x squared over 2L, right? Then multiply by x over 3, right? Anything else? Then plus by m as a function of x, the whole thing will be equal to what? It will be equal to 0. Okay. So I'm going to write down m as a function of x will be equal to I want to pick the biggest term first. Okay, so will be equal to minus omega naught x cubed over 6L. Okay, and I have I think I have an x term missing. I think this has to be covered by an x. No, that's the moment. Sorry, that's the moment. I don't need to cover it by the x. Okay, omega naught L squared. Yeah, it's a moment already. Okay, then over here I need to plus by omega naught Lx over 2 minus by byx. Okay, then our minus by omega naught L squared over 3 plus by byl. Okay, so once I remove the bracket, plus by omega naught Lx over 2 minus by byx minus by omega naught L squared over 3, okay, over 3 plus by byl. Okay, let me check. Byl omega naught minus byx plus by and minus. Okay, so then from here we know that this equation over here, right? This will be equal to what? EI d squared y over what? Dx squared. Right? Now we recall that, right? So now this is where we apply, because this whole function over here is m as a function of x. Okay, so this is where we apply the elastic curve. Okay, now this is where we apply elastic curve. Okay, this is where, oh, you all can't see now. So that's where we apply the elastic curve. Okay, this is where we apply the elastic curve. Okay, so from the elastic curve, we know that EI theta or EI, we integrate. Okay, EI dy by dx is equal to EI theta. So this will be equal to what? Minus omega naught x4 over 24L, right? Plus by omega naught Lx squared over 4 minus by byx squared over 2 minus by omega naught L squared x over 3 plus by bylx plus by C1. Okay. So this I will call, I don't know what equation I'm in already. I don't think I call any equation, did I? Okay, I'm going to call this my equation number 3. Okay, so we have reached our equation number 3. So by reaching equation number 3, we can use our first one of our boundary condition. Okay, we're going to substitute. So we're going to substitute where at point A, right, where x is equal to 0, the slope is also equal to 0, right? So if we were to recall, right, we'll recall when x is equal to 0, the slope is also equal to 0. So we're going to use that. Okay, so when that's the case, from there you can see that, therefore, C1 is also equal to what? 0. Everything is equal to 0. So from here we have EI theta is equal to minus omega naught x4 over 24L. Okay, plus by omega naught Lx squared over 4 minus by by x squared, okay, over 2 minus by omega naught L squared x over 3 plus by by Lx. So this is our equation 3a. Then we integrate again. Okay, so we have EI y now. So minus omega naught x5 over 120L plus by omega naught L x cubed over 12 minus by by x cubed over 6 minus by omega naught L squared x squared over 6 plus by by L. I think you guys are better in integration than me, okay? So this is our equation number 4, okay? So from equation number 4, I'm going to use the next page. I ran out of page, okay? You guys are still copying? I'll wait for a few more, 1 minute, okay, for you to catch up. Are we good? Okay, I have no response whether
Yes.
you're good. Okay. So from here, right, we're going to substitute. When x is equal to 0, y is also equal to 0. Okay. So what I'm going to do is I will copy the entire function so you can see. I'm going to copy the. Right. So over here, what we have now is this. Okay. So we're going to substitute into equation number 4. So from equation number 4, everything is equal to 0. So therefore, C2 is also equal to 0. Okay. So we have EI y, right, is equal to minus omega naught x5 over 120L plus by omega naught L x cubed over 12 minus by by x cubed over 6 minus by omega naught L squared x squared over 6 plus by by L x squared over 2. Okay. And then the last one, we're going to substitute when x is equal to L, right? Y is equal to what? 0 into equation what? 4a. So that is the other side of the support. So that is this side of the support. Okay, so you look over here, right? So if you look over there, that is the support that we have, right? Where x is equal to L, y is equal to what? 0. Okay, so you move over here. Okay, so now we have 0. This will be equal to minus omega naught L 4 over 120 plus by omega naught L4 over 12 minus by BYL cubed over 6 minus by omega naught L4 over 6 plus by BYL cubed over 2. Now you can see that this equation, we can find our what? BY now, right? So I'm going to, so 1/6. Okay, so 1 over 120 plus by 1 over 6 minus by half. Okay, so minus Hold on. 1 over 120. Omega naught L4 over 6. I think I probably had something wrong. Hold on, people. X4 is over 6. BYL cube